All right, we'll look at our flight release here real quick. I have an example of an actual airline flight release, and we'll make some of our own modifications to that and provide flight releases for you when we get to the end of our course. And so you'll need to know how to read this. I'll go through and show you everything on it and point out what exactly you'll need to know for our course here at Purdue. Getting started, you'll notice the first page here is just a cover page for the release. We have our, it's just a load report. So we have our flight number, we have our departure airport, destination airport, tail number of our airplane, which gate we would be parked at if that was known ahead of time, and the date. This is just a quick look for the captain and the ground handlers and gate agent to know what kind of weights and baggage they'll be expecting on board. So here we see in bin 3 we have 55 bags for a total of 1,650 pounds. And there's our bag code. B means they're all bags. You can see the other different codes down at the bottom of this page. We also see that we are flying at 320 today, and here's our passenger expected load for a total of 131 people and how much weight we have to work with. 16,886 pounds. On the next page, we get a little more information. We again have our tail number, our date, how many seats are on the airplane, scheduled time, both local and Zulu, and now we have our fuel numbers. So preferred fuel is how much that we want on the airplane when we leave the gate. Our min fuel is how much we need to do to make our flight successfully. And then brake release fuel is what we want on board when we release the parking brake at the start of our takeoff roll. You notice the difference between brake release fuel of 11,900 and our min fuel of 12,200 is 300 pounds, which is exactly our taxi burn. So we have to have the 12,200 when we push back from the gate, because if we don't, we will probably burn a little bit more than that on the taxi, and then we won't have enough fuel to make the flight. The fuel numbers here, if you remember from your instrument lecture class, gives us enough fuel to get to our destination, then our alternate if we need one, and then 45 minutes extra. So if you have 11,800 on board when you release your brake to roll down the runway, now we only have 44 minutes extra at the end of all of that, and you're illegal per FARs. So you do have to make the decision here if you're getting close to that 12,200 before you push, whether or not you call the fuel truck back to get some more fuel on now, or if you risk taxiing all the way out, doing all of your flows and checklists, and then needing to taxi all the way back and wait for the fuel truck after that. So that's one of the decisions that you'll have to make as a captain. Our planned maximum takeoff weight here is 155,800 pounds. And that's again our planned maximum. It's not our planned actual takeoff weight, it's just a theoretical maximum takeoff weight. And that is based on, there's several different codes. This one is LS, which means landing structural. So we can be limited by our takeoff structural weight, we can be limited by takeoff runway distance, landing structural weight, en route climb performance with single engine. There's a whole plethora of codes out there, and so every airline will have its own set, and you'll need to learn that to know what you're looking at if you get pressed up against those weight limits. Again though, our planned payload though is only 26,000 pounds, and we have a payload capacity of 43,000 pounds with that maximum takeoff weight, so we've got plenty of room for today's flight. We see our MELs. Today is nice because we have none. Down here would be the list of the crew. We'd have the badge numbers and then the crew names here, and the dispatcher name and what desk he's sitting at. So if we need to call dispatcher in flight, we can pass along what desk he's at and get to him faster. Quick note here on the crew names. You and the captain will probably know each other pretty well, but you'll want to, if you don't know the people, you want to look at their ID badges and make sure the numbers correspond with what we have on the release here. And the person who started that was Frank Abagnale from Catch Me If You Can. So next page. Here's where we get into the more nuts and bolts of what we want, and this is what we'll do the release brief from when you brief the flight attendants and the first officer about what's going on. What that would look like is we'd put check marks on this page as we read through that. So I'll give you a sample release brief and then we'll talk about what I said. So this is Purdue Airlines release number flight 2306. We're going on September 7th. It's an IFR flight plan from Nashville to Philadelphia, scheduled at 16:56 local, arriving at 19:56. We are certified for Cat 3B. There's no alternate required. We have 12,600 on board. We only need 7.3 for our flight. We have the right tail number. 186 on board. We have 5,000 pounds, which gives us an hour, 15-minute extra. We are flying at flight level 370 on the Chatham 3 to swap, Jet 42 Gordonsville and the PATS 3 arrival, hour 32 minutes in flight. Max takeoff weight is 155 and we're planned for 137.3, no MEL CDLs, no remarks, you, me, and all the flight attendants. And then I'd sign down here and initial that I have enough rest, and first officer initials as well. And George is our dispatcher. So that's what a release brief looks like. So what did I just say? We'll back up here and look at all of these items one at a time. Again, we're starting out with our airline name, our flight number, day of the month. Those are pretty straightforward. IFR, of course, because we're 121. Departure airport, destination airport, departure times. This airline is low cost, so they even put in fuel cost per gallon, which is something you don't see on every release. This line here about your status is very important. It says whether or not your airplane is capable of Cat 1, Cat 2, Cat 3 approaches. It doesn't mean you have to do a Cat 3, it just means it's capable of it if that becomes required. And then you'll want to match that up with placarding in the aircraft to make sure that the maintenance has all of their chips in a row as far as what gets put down. Our alternate, it's nice to see not required here, but we do of course want to check in the weather, make sure the dispatcher knew what he was doing and didn't just enter no alternate when we actually needed one. Again, we see our fuels. This is how much fuel we want to have on board, flight number, or I'm sorry, tail number, how much fuel we want for brake release, how much we're burning this time. We're going to see this number, 7.3 en route burn, taxi burn, and then that gives us 5,000 pounds at our destination. Again, we have, this is our IFR flight plan. So we have our flight number, it's an instrument flight number, or a flight plan. It's an A320, and then this is our equipment code. The S stands for ComNav, D is DME, and etc. They used to make sense back in the day, where you would probably have a C for ComNav, but they switched from the FAA standard to the ICAO standard a few years ago, And now even air traffic control will call you up in the air and say, what does this code mean? And you'll say, I have no idea, I can look it up for you. And they say, don't bother, we have no idea either. So it became a little bit more useless with the more confusing code letters, but there are reference charts and you can spend time memorizing that if you want to. I haven't found it extraordinarily helpful in my career though. We have on this next line, it's a little bit obscured. The true airspeed we'll be flying is 451 knots, and then our altitude is flight level 370. And then we have our route of flight. It's a Chatham 3 departure, swap transition to the Jet 42 airway, Gordonsville transition to the PATS 3 arrival, and to Philadelphia. Our next line is performance-based navigation numbers. This is how accurate our RNAV and inertial reference equipment is, and so the ATC can put us onto tighter and tighter airways as far as spacing between other aircraft. We have our survival equipment. Since we're over water equipped, that code lets us know how many life rafts and life vests are on board for emergency purposes, registration tail number, and then if they're going to contact us in flight, we have a cell call code and aircraft number. Again, we see some repeated information, planned maximum takeoff weight, and then here's our finally actual planned takeoff weight, which you'll notice is that 16,000 pound difference that we saw on page 1. And our maximum taxi weight is 178,000 pounds. So these are our planned runway takeoff weight, is 178,000 pounds. So even though that's significantly higher than the structural maximum on the airplane, the runway is long enough to take off if it was that heavy with our engine. So it's just an engineering theoretical number of what the engine performance can do and not necessarily what the airplane landing gear structurally can hold. We have an en route takeoff weight, which is 198,000 pounds, which is even higher than our 162,000 pound maximum takeoff weight. We've got an extra 30,000 pounds on there. And again, that's just an engineering theoretical number. If we lose an engine, what can our single remaining engine do to clear all of the obstacles in between us and our destination? You'll see this is method number 1. They have 2 methods. Method 1 just gives you your straight up climb out and then 1,000 feet over all obstacles. It's the primary method you'll see on the East Coast because there's not anything high enough on the eastern half of the United States to really get in our way. Once we get out closer to the Rockies though, you might occasionally see a method 2 as they plan for avoiding some of the higher mountains and our lower air density environment. Next line is planned landing weight is 130,000 pounds. You notice that's exactly 7,300 pounds less than our takeoff weight, which is exactly our en route burn. How about that? And again, it gives us a max landing weight, and that's 148.6. And that is, again, for our landing structural. We see our MELs. Once again, we have no MELs on board, no remarks. If your dispatcher knows the flight crew really well, he might put in a "Good morning, how you doing, Bob?" on there, or he could put in something more pertinent, such as, I changed your route because there's thunderstorms in the area, something like that. So he can let you know what he's thinking about with a quick remark there. Again, we have our crew checklist. We have 4 flight attendants on board because we have 186 seats, which is 1 flight attendant per every 50 seats. And then the captain, of course, has to sign the release to say that he believes this flight may be made with safety. So you get 3 copies of this. You'll notice this is page 3, and on the next page you'll see it's page 6 because 2 of these pages, 4 and 5, one was handed to the first officer and the other one was handed to the gate agent. And if for any reason you should crash, the gate agent can hand her page to the NTSB and say, see, he signed it, he's going to make the flight safely, it's pilot error. The dispatcher would sign it as well, and by putting down the time that he created the release. And so that's an effective electronic signature that the dispatcher believes the flight can be made with safety as well. And then we have our part 117, did you sleep well last night? That's code for are you actually legal rest rules wise. And so you initial on there and you're good to go. Next page, we get into some more of the details of the flight. So again, we see our flight number, date, header information here. And then we have a quick note about Nashville's outside air temperature. And we get an erroneous bleed leak message if we don't set our flaps 1 when it's hot outside. So that's just something you want to pay attention to. Look at the temperature when you see that. Probably it's not going to be more than 35 degrees outside, but that's pretty warm. Briefing item, here in Philadelphia, the operations can only transmit and not receive radio calls. So if you try and call in range on the radio, they won't hear you. So you'll have to use ACARS to get a hold of them, or just hope that they notice you're on the ground when you get there. Then we have our a little more of our planning information. So this is route number 1, flight plan number 1. If they made any edits to that, then they'd change that to 2 or 3, and so on. We see our cost index right here. That's pretty important, and you'll want to know where to find that number, because that lets us know if we are, the higher the cost index, the faster the plane will fly, the more fuel will burn. The lower the cost index, the slower the plane will fly, and the less fuel will burn. So higher cost index is time efficient, lower cost index is fuel efficient. This one's very fuel efficient down here at 17. We'll see our aircraft type, our engine numbers. We have the LEAP 1A engines, which is the new engine configuration. There's also the conventional engine configuration, CEO, but for our class, we'll be using mostly the NEO version. Here's a more specific fuel layout. So we again have our burn fuel, how much time we're flying there. That's our hour 32 en route. It's a repeat from what we briefed on the flight release. Our contingency fuel, we have 25 minutes extra. Our alternate fuel, we have nothing since we have no alternate. Our reserve fuel is exactly that 45. And our brake release fuel is 11,900. We need that on board to take off. Our extra fuel, they gave us 5 minutes of extra fuel. And our tanker fuel, nothing coming along with us. Taxi fuel is 300 pounds for a 12-minute taxi. And then our ramp fuel, all of that added together is 12,500 plus 9 minutes of taxi in fuel that we're hoping to use our reserve for. Then our fuel remaining at destination is 5,000 pounds for an hour 15 minutes. And if we have changes en route, we have a little spot here where you can do some calculating to figure out how much extra fuel you need to load before you take off, or how much fuel you'll have on board if you're doing some changes en route. Here's our actual flight block time, is an hour 53. You'll notice on the previous page we said 1 hour 32. That's only the en route time, because the FAA doesn't care how long it takes for you to taxi out or taxi in. They're going to start that timer to track your plane when ATC clears you for takeoff. And then once you hit that 1 hour 32 plus 15 minutes is when they go out searching for you if they've lost your airplane. We'll notice here, for calculation purposes, every 1,000 pounds of additional weight, we're going to add 45 pounds of fuel burn. Here's some important numbers. Is our average wind component is plus 13, and our average temperature is minus 53. So we'll want to know that for our init pages on our FMS preparation. Again, we have the copy of the Ifr flight plan. We've already went through that, so I'll skip that. We see our planned altitude, cost index, and en route time. Next page. We have our IFR point-by-point flight plan, which is something I'm sure you've seen in your training here at Purdue, where we have every single point. We have GPS coordinates, we have flight level, winds, temperature, magnetic heading, magnetic course, and speeds and fuel burns. So as you're flying along, we have a couple floating points in here. We have our top of climb and we have our top of descent. If ATC held us low for a long time and didn't climb us, this top of climb might move past GATS. If they start to send us down early, top of descent might move forward, and those will change our fuel burn numbers. So at the first point you get to after you reach top of climb, you want to compare your actual fuel burn and fuel on board to what you have on the airplane, and then recalculate how much fuel you have remaining there. And then you'll want to make it a couple more points through the flight. Especially on the longer flights, your airline will require you at certain points to check your fuel, just to make sure you don't get halfway over the Gulf of Mexico and then realize that you can't make it the rest of the way. We get down to the end of our flight plan, and then we have our winds aloft chart. You guys know how to read those, so I'll skip over that mostly. And then you'll notice that we only have winds aloft for upper altitudes 180 through 390 until we get close to our destination, and then it gives us winds aloft for, that's exciting, our lower altitudes. Next page, we have our takeoff and landing report. Here's our takeoff data. If all of this information exactly matches our current conditions, we can use these takeoff numbers. But otherwise, we're going to come down here and reference this chart. Dispatch can give us some remarks there about anything interesting he did with his takeoff conditions. Now, Nashville, where we're taking off, only has 4 runways, so that's 8 possible directions of runway, but we have a whole lot more than 8 runways listed here. The reason for that is that we have all of our intersection departures, runway 2 center at Sierra 1, and then 2 left at Bravo 2, etc. It tells you how much runway you have available at all of these places, and it gives us our max takeoff weight for all of those intersections. So if we plan to take off at runway 2 center and air traffic control said, Purdue, can you take off of 2 center from Sierra 1? We'd flip open this page real quick, look at it. Our planned max takeoff weight is the same, so we don't need to adjust anything, and we can say, yeah, we can accept that. Now, if our runway got exceptionally short, say we got down here to this 5,000 foot runway, and for some reason they had changed that number to 136,000 pounds. You'll notice our takeoff weight was 137. We'd say no, unable on that one. we'll have to take full length. Down here is where we'll figure out our takeoff numbers for these runways. And so if we're taking off of runway 20 center, we'd come down to this line. Our max takeoff weight is 137,200 pounds. This is now a maximum takeoff weight for this specific planning. It's not for our landing structural anymore, which is why we don't see the 155,000 pounds. We're going to reduce our engines to a 67-degree flex. We'll still keep our packs on. We'll take off with flaps 2. Here's our V speeds. If we have an engine failure, we will do a right turn to a heading of 220. So that'll be a 20-degree turn, probably to avoid some obstacle off the end of the runway there. Now this is for a dry runway at our planned takeoff weight, which is 137,000 pounds. Now if we're going to add 4,000 pounds or even 1 pound beyond our planned takeoff weight, we jump to this next line. And you'll see it goes up 4,000 pounds for our max takeoff weight. We're now going to flex to 65 degrees, so a couple degrees off of our flex. No change in the flap position, but we do add a little bit to our speeds. And again, the engine failure procedure is the same because the obstacle doesn't move just because we added weight. Then if we have more weight and or a tailwind, then again we'll come down to this third column, put on even more flex and change our takeoff numbers again. So you'll just cross-reference whatever you have here. You'll notice these are all dry runways, and if it started raining, you'd have to call up dispatch and get new numbers. And if there was rain in the forecast, he would probably have those numbers already in there for you. We'll see on the next page. It goes straight to landing data though, so it looks like it's going to be a pretty dry day in Nashville. Here at Philadelphia, again, here's the planned ATIS. So we're planning on landing with flaps 3 and a landing weight of 130,000 pounds. No remarks. Here in Philly, they only give us the runways that are available. There's not that long list. That's because we're not going to do intersection landings because it's not Oshkosh. Runway length, any NOTAMs available to us. It doesn't give us any data for landing speeds because the planned en route burn is only a theoretical number. And there's a lot of changes atmospherically or air traffic control wise that can increase or decrease that fuel burn, and they're not going to make the giant chart that shows all of those possibilities. And you'll get your landing data numbers through ACARS as you approach the airport, and you have a more accurate view of what your actual landing weight will be. Next page, we get into our weather report. Here we have our METAR for Nashville. They give you a couple hours earlier of METARs and then a TAF. So you can look through there and see that you've got great clear skies. There's no need for any wet runways. You can look at your wind trends, see what's going on there. And you guys know how to read METAR, so I'm not going to explain that too much. We have our NOTAMs for Nashville. We have some good ones, such as the very first one, ILS runway 2 left, Cat 2 not available. So if our weather went low, we'd have to do a Cat 1 landing if we were planning on 2 left, or we'd have to switch to a different runway. So just because we have a Cat 2 or Cat 3 approach chart in our book for runway 2 left doesn't mean we can use it. We'll have to look at that NOTAM and make sure it's actually usable. Next page, we finish up our Nashville NOTAMs and we get down to Philadelphia weather. Oh, it's doing that exciting thing. We have our current Philly METAR and our TAF. The TAF here is important. We'll see that our dispatcher was correct. We do not need an alternate airport. But here's a spot where you can look through the previous METARs and see weather trends. So if you see visibility continuously reducing or cloud layers starting to form and come in, it might be a good idea to call up dispatch and say, hey, you know, I noticed the TAF says it's going to be nice weather ahead of us, but I see the trend in the METAR is going downwards. Do we still trust the TAF? And there you and the dispatcher can have a little bit of a conversation and say, you know, that TAF is pretty old. We don't trust it anymore. Let's go ahead and add some fuel just in case, or maybe we'll add an alternate just in case. Or maybe the dispatcher will say, you know, that's just the morning fog bank that comes through Philadelphia every day, and by the time you get there, it'll be all cleared up, so don't worry about it. Either way, it's good to look at it and think about it, plan ahead a little bit. Again, when we have more NOTAMs here in Philadelphia, so here we have a nice one, Philadelphia taxiway Lima between 9 left and taxiway Kilo is closed. So you'll want to know that if you land on 9 left or 27 right and you're planning for your runway turnoff, you can't turn off there onto taxiway Lima. And so you should plan your rollout accordingly. Since this is a summertime flight, we have a little bit less useful NOTAM. The de-icing apron sign, direction sign for lane 2 is missing. That's, you know, absolutely useless until wintertime. But you'll get good as you get experience in the airlines of reading through all of these and sorting through which ones are actually pertinent to you and which ones are not. I would recommend practicing though, you know, pull up NOTAMs for airports, and as you go into the airline world, especially when you're new, take some time the day before your flight and look up the NOTAMs for all the airports you'll be going to, just to get familiar with them, notice what's going on there, and do it in the comfort of your hotel room or your apartment so that you can you know, use your internet translators and everything to make sure you know what you're reading when it comes at you in the flight. We have more NOTAMs here on page 14. You'll notice the Nashville NOTAMs took about a page and a half. Here, Philadelphia NOTAMs started back on page number 13. And as we skip through, it's all a lot more NOTAMs all the way down to page number 38. One of the reasons Philly is so long is because it's close to, that's not it. One of the reasons Philly is so long is because it's close to Washington, D.C. So we all have the ADAS NOTAMs built into there, and that's going to be in every single flight you get to the Philadelphia, Baltimore, Washington area. So this one is extra long. Make sure you do read through it though and get familiar with it. After you're exceptionally familiar with it, as you recognize that it's the same NOTAM, you can start to skim a little bit more, but do make sure that a change doesn't sneak up on you. Okay, so that's a release. What you'll want to know for our class is especially important is our fuel numbers. So you want to see this one right here, Nashville, we want 12,600. I'll be asking you how much fuel you want on board for your flight. That's the number you want to say. You want to know how much you're going to burn and if that's enough for your destination. You want to be able to read the flight plan, especially knowing that this is your route. That's where you'll be putting in to your FMS when you do your FMS preparation. And you will want to know your cost index. That goes into your FMS preparation as well. And then you'll want to be able to read the takeoff and landing report and put that in as well. So those are the more important pages. Everything else is just to give you a first glance before you experience it out in the real world.